Okay, we are live. Welcome to week 5 or module 5 of whatever this class is called, doctoral stats or something like that. So what are we working on this week? We got ANOVA and we got chi-squared. We have our checkpoint 3. So we'll go through those tonight. Yeah, I'll kind of let you all set the tone and the pace on what we want to review. Several of you have already emailed with on the problems and what we were looking at in terms of the ANOVA analysis and the chi-square and Kramer's. So does anybody want to start with any questions, or how do you want to go about this one?
You know what? I'm just gonna ask again first. I'm at a point where I need to do that checkpoint, and I just don't know how to do it. So that's the part that I'm most interested in right now.
The checkpoint 3?
Yeah, the research design and methodology that we have to do.
Okay.
And again, it's up. I know that's gonna take a little bit, like a while, to go through. So if they want to do exercises first, I'm fine with it.
Well, I think the easiest way to think about this one is compare what the articles you're using, how they set up their basically third section or their research design or empirical analysis, whatever they call it. And ideally, what we're driving to do here is look at prior research to kind of guide you on what your testing options are. Again, we're only going to get to descriptive statistics, and I'll probably have you do a hypothesis testing, just some like analysis of the mean type stuff this term. But next term, we'll do the full analysis. But so when you're looking at the articles, goodness, I got a B here, sorry. You'll see that they identify their variables as, particularly if they're doing regression or something like that, they'll identify their dependent variables and their independent variables and their expectations of that relationship. And usually that is grounded in literature. Okay, so again, use the articles that you have that you're developing your lit review on as kind of the framework. So in terms of, chapter 1 of the introduction and the context of the problem or significance of the problem, in the addition to the literature, all of that fun stuff, you'll use your research and literature in there, and then you'll have chapter 2, which will be your actual lit review. That'll be a little bit longer. But throughout those articles that you're using in both those sections should be the seminal and foundational quantitative and methodological approaches that you're going to take. Okay. So every article that you use that's published in an academic journal has the same framework that you're doing. Chapter 1, chapter 2, chapter 3. Ideally, they're not called chapters, but and then the empirical analysis or the results, and then the conclusion. So within all of that, typically in the third section on the empirical design or research design or whatever they call it, they'll walk through why and how they developed it the way they did. Okay, so prior research has done it all. Nobody's creating anything new, but you'll want to use a similar approach as to what's been identified in your research that you're using for your to justify your project. Does that make sense? Okay, so it's all laid out before. Someone's done it before you. I'll go out on the limb and say a lot of people have done it before you. And so you'll just want to see how they did what they did and why they did what they did. And then as you grow that, and you get the baseline, that's when you start to identify your variables and the relationship between them. So stick with me on the relationship part, because we're going to get to the model development here in a minute. But develop some initial hypotheses, and it's not about being right or wrong. It's not about any of that stuff. It's just what is your hypothesis? Like for mine, my hypothesis 1 is higher levels of CEO ownership concentrations in the banking industry make them more resilient against exogenous shock. Sure, whatever. Doesn't matter if it's right or wrong. That's the hypothesis. Okay. And then my job is to go out and test it empirically. Mandy?
Okay, so can you hear me okay? Okay, I've got headphones in, so I didn't know if they had a mic. So several of the seminal studies that I'm using, they did a lot of regression models and predictive factors. So that is something that I could potentially do for my long-term dissertation project, but is that something that I should consider for this week's assignment, or am I just focusing on something that I can get done for this class?
Yeah, a little bit of both. Go ahead and list those in there and what they did and what you might drive towards. Again, this is week 5 of 16, really, right? So if there is some sort of research design that you're like, I think this can work. Then let's go ahead and mention that and say this is an opportunity for, testing, if you want to say it that way. So because that'll help in that section, it'll help say, okay, so-and-so did it this way, so-and-so did it this way, so-and-so did it this way, and here's what they found. That it's you will not believe how redundant the chapter 1, 2, and 3 are in terms of the seminal works and what they did in terms of this is what they identified. This is their addition to literature, and this is how they quantitatively did it. So you have this overarching utility when it comes to these seminal sources. Now, if you have something that's like, the Journal of Bob and Sarah or whatever, it may not be a seminal work that needs attention, but it could still be a good model. It doesn't necessarily need to be a part of your chapter 1 framework, but it can say, Bob and Sarah found, a one-to-one relationship in CEO compensation and firm performance when market cap was, something like that. Just figure out what you can use with these sources. Because again, I don't want you all trying to create new theorems, or you're just not going to do that. There's just nothing left to do. I'm sorry. All we're doing is recreating things because the glory days of the 60s and 70s and 80s are over. So yeah, does that help? Okay. Just one second. Sorry, my idiot dog's outside. Just a second. Come on. Go. All right. Okay, so then what we'll do next is, so we start to look at some hypotheses, and then this is going to be the hardest part. At least it was for me, because I'm a quant brain and I'm very linear, and in finance there's a formula for it. Why do I need a model? I don't need a model to show the relationship between variables. It's identified in the quantitative model, but it's something we all have to do. And so hopefully you all will check out that building a theoretical case model. That one does a really good job of showing how you construct your hypothesis 1, hypothesis 2, hypothesis 3, and whether they're positive or negatively correlated. Again, it's not about being right. It's about having a hypothesis that you can test. Okay. So if we say risk-taking incentives have a negative correlation with long-term firm performance, we may test it and find that it's positive, but at least we know, right? It's not about being right or wrong on the null. It's about testing it and either failing to reject it or rejecting it. So try to wrap your heads around, it's not about you're not right or you're not wrong. You're just testing data. Okay. But you will need to develop a conceptual model of your variables and how they interact with each other. And we're going to do this at residency, and I'm going to show you my first one and show you that it sucked so bad. And I was told to go back to the drawing board, and it's just part of the process, because conceptual models are very challenging, especially when you haven't necessarily collected the data at this point, right? Or even analyzed it. But that's okay. That's what we're doing, is we're gonna develop a conceptual model, not a set in stone model, conceptual and theoretical model about how our variables interact and the objectives that we're trying to test in terms of our hypotheses. Okay, Paul?
Yeah, you brought up to make sure we look at the building a theoretical model. Is that just something that's in this module?
Yeah, look in the assignment area.
Okay,
Yeah, there's a
thank
link
you.
there that says building. Well, there's examples in the term checkpoint 3 area, but there's also examples below, and via this link, building a theoretical case models a link to a website.
Thank you.
And these can be extraordinarily complex. At this point, they don't need to be. But that's really where I want you to start looking at, again, theoretical, not application-based model. Okay. So let's think here. I'm trying to think of a good one. Mandy, with yours, the assumption is the dependent variable is going to be retention or end of class grade. What are you thinking?
End of class
and again, we
grade.
can have two. Okay.
Yeah, for
Let me-
now, it's end of class grade.
Okay. And so the independent variables that will affect that will be.
So for right now, for this class, I'm looking at underrepresented minority groups and non-underrepresented minority groups.
Okay. All right. That'll work. So we'll have a 1-to-1 there. And so, luckily for you, you did ANOVA as your chapter. We'll be able to look at some analysis of variance between the two groups, between them and within them. And we'll talk about that here in a little bit. But I do apologize. I haven't had a chance to look at the articles you all did last week yet. I was suffering through my own dissertation the last couple of days. So at least I'm enjoying this process with you. So, all right, then we move on to, you must have completed the following for this project. Again, there's kind of a breakdown after that. It says identify your dependent variable of your choice. Even if we're going to go with something like hypothesis testing, we'll want to, at least in terms of the dependent variable, figure out what our hypothesized mean will be and then test against that. We'll look at our independent variables so that we can, select a response. Again, we can do a quantity or a categorical variable. It's up to you. That will affect what test you can do, but we'll get to that in the coming weeks. Independent, dependent, or quantitative, then perform correlation and regression analysis. That's kind of a jump ahead. You don't necessarily have to do that at this point, but I'm just kind of gearing you all up for that process. Okay. And then it talks about, or it gives some examples of like a detail of a study. So our problem statement, our measurements, and then a sample of a model. And then there's that link as well. So I'm trying to think. Yeah, I do know that in the end, you'll need at least 100 variables or 100 observations. I'm sorry, not variables. So based on that, questions?
So I am feeling probably the least confident about this assignment for whatever reason than anything that we've done so far. So what I'd like to know, depending on how you answer this, it may make me feel better. If we put something together and hand it in and it is horrible, it sounds like you're willing to give feedback and, we're going to get better. Am I interpreting that correctly, or do I need to like put all of my blood, sweat, and tears into this project to try to get it right the first time?
You're out of the DBA program if you get this wrong. So good luck to everybody. No, yes, absolutely. What we're here to do is learn what we can and can't do with our variables, right? Someone will undoubtedly put in categorical variables and try to do a hierarchical regression analysis. It's not going to work, right? So, and vice versa. So you know, it's all about testing. It's all about learning. I hope by week 5, you all realize I'm not here to hurt you or, you know, give you any more anxiety than you already have. So no, I mean, let's run with it, but I would encourage you to email me this week. Don't fumble through it until Sunday night and then turn in something you're unsure of. I'd rather work through that via email or a phone call or a Zoom or something like that. You know, so I hope does that answer it?
Yeah, I think so. Again, every time I go to start this, I just get panicky. And so I thought, well, I'll wait until we meet on Tuesday and see if things clear up.
Yeah.
And so I anticipate that I will probably be emailing you a lot of trivial questions at first until I get some traction. And then hopefully it will start to make sense. But I just feel really, I don't know, just blowing in the wind at this point.
Yeah, and that's probably how you should feel, because we don't know what we're doing yet, right? I mean, we haven't even taught. Next week we get to regression. In theory, most of you will probably do regression, but we haven't even explored it yet, let alone how to even figure it out in Stata. But part of this process is getting it wrong a couple of times. I will give you an example right now. When I took this class in my DBA program, I did testing of full-time versus adjunct faculty and student outcomes. And I decided to go with an ANOVA, and my professor let me run with it. I was wrong, and that was okay. You know, he told me why I was wrong. And then the next semester when we met again, he had already informed me the right way to do it. And, you know, we just kind of worked through the minutia. Now, we're not doing that high level testing. Again, we're just doing descriptive statistics and a hypothesis test or something, you know, an analysis of mean. If somebody wants to get wild and do an ANOVA, they can. But ideally, this is more about setting the foundation for next term, when you will have more time and more bandwidth to do the quantitative side of it. Right now, you're so bogged down in terms of not only learning the basic statistics, the framework of each statistical analysis, but you're also learning how to do it in Stata. You're also doing a research project. Next term, we're going to stay mostly focused on the research project with some higher level statistical analysis options out of the textbook. So even if you lock into something now, it doesn't mean you're locked into that for the next, 11 weeks or whatever it's going to be. You're going to have time to adjust. You're going to learn more. You'll figure out what you're doing right, what you're doing wrong. I hope that answers it. But yeah, you're not going to be any worse for the wear if you say, hey, I want, these are my variables. This is what I'm thinking. But the main thing, though, is helping me, because I'm not going to be an expert in every area. So that's why it's so important to have the literature to support your thought process and your development. Because if it's there, then I trust that you're interpreting it the right way and you're using their framework and just using your own data set within it. Paul?
Not to be solved here, but I'm still having trouble finding a data set. So I'll email you about that.
Okay. It is important that you find yourself a data set, and even if it's tangentially attached to what you want to do, you might need to shift your topic. Okay, because we can't just make data sets out of thin air. So for any of you that are struggling with the data set, you might think about a more achievable outcome, because there's a couple of topics out there that I'm a little worried about, but we'll figure it out when we get there. So, but yeah, just trust yourself, take some chances. Again, if you mess up, we'll circle the wagons and we'll try again. Okay. Okay. Anything else on checkpoint 3? Okay, just don't forget, turn in the type description of the sources, the data type, the variables. Okay. Then we just have ANOVA. Now do make sure. God, it scared me. Let me see here. Everyone on here has already turned in their presentation to the discussion forum. So thank you. You only have to respond to 2 peers this week. Okay, not everybody. So really this week isn't too bad. And I say that because the homework's really not that bad either. Despite what Mandy will tell you, it's not too bad. So what questions do we have on it? So what's ANOVA? Someone break down ANOVA for me. What is that? What are we testing with ANOVA? What does ANOVA stand for? Come on, guys. Look, I was up till 3 a.m. writing and back up at 7 a.m. for my dissertation. Y'all better get some pep in your step or I'm going to go to bed now. So what's it going to be? What's ANOVA?
Just analysis of the variance.
All right. What does that mean? What can we test with that?
The impact of like
Go ahead, sorry, Jacob.
I might be wrong. I was gonna say, so like the impact of like obviously the independent variables, which are probably more like regionalized, like I to me it makes sense thinking of it like geographies and that impact on your or your dependent variable.
How about categorical? Does that fit better?
Yeah, that sounds way better.
Okay. All right. You're right. Because what we're doing is testing differences between groups or the variance between groups. And we'll get to this next statement, but within groups as well. So what we want to do is a particular group more likely to do X or Y? And then how do we defend that based on the outputs that we see? So there is, again, just like there is in each chapter, examples of the variance within certain fields. So like economics, does annual income vary across regions in the US? Well, yes, it absolutely does, right? And so the null hypothesis would be there is no difference in annual income across regions in the US. I can go ahead and tell you we're rejecting that null hypothesis until the cows come home. So it's not something that we need to worry too much about. But our continuous variable is our annual income. Now, here's where we get into it is our categoricals where we're going to break it into regions. And so we might say Midwest or West or, for Paul, the Pacific Northwest or however we want to look at it. That's going to be our categorical variable where we look at the different groups, but we're testing the same continuous variable. That's just annual income. We're just looking at different regions. Okay. And what this is going to tell us is most likely West Coast and East Coast, if we were to break it down in some sort of fashion like that, are going to have higher annual incomes because of cost of living. Us poor folk in the Midwest who are immune to recessions and things like that, we make a little bit less money, but we don't deal with the variance that's related to income and declines in economics. Or the economy. So now the calculating the F ratio, this is important. What does the F ratio tell us? And these are all fancy words for the same damn thing. Z-score, T-stat, F ratio.
The way that I interpret that is the total of the variance between the groups and within the groups.
And whether it is?
Well, I would say, but I don't know if it's right. If it's statistically different from the alpha value, right?
Yeah,
Or is it statistically
significant.
different from each other, right?
Yeah. Yep. Between the means, then the means. Okay. Okay. So again, it's just going to be, if you remember that Z-score formula, right? We do the observation minus the mean divided by the standard deviation. This one's a little bit different, but again, we're hunting the same outcomes. We're looking for statistical significances based on variances of our observations. Okay. So the formula's in there. Again, there's a two-parter here. There's the numerator and there's formula, and there's the denominator formula. And these are a little bit fun to deal with, I guess. So Mandy and I hashed this out the very first week because I couldn't make it work. And then it dawned on me as soon as we both gave up that, oh, no, I figured it out. So what we need to do, though, is this one we're just doing a one-way ANOVA. We're going to get into MANOVA next term, which is, either a two-way or a multiple way analysis of the variance. It's going to be a little more complex than this, but for this one, it's not too bad. So all we're trying to do is figure out the variance between the group, the two groups, or the multiple groups, and then within them. So what we're trying to do is determine if the variance is significant or not, and then the accompanying alpha level and outputs like that. So the questions this week do a very, I think, straightforward job of walking you through some of the coding for a stata. Do not overthink this. It's a very basic formula for a lot of these. But what I'm going to do is go through a question that is very similar to question number 2. Okay, so if we look at question number 2, it asks us about, I will share my screen real quick. Okay, it was, okay, this is question number 2. So we're provided with the average hours of gaming on a weeknight between these age groups, okay? And we're provided with the variance, so they did all the legwork between observations, minus the mean, squared, all of that. And then we have our sample sizes, okay? Now, I'm not going to walk through that one, but I'm going to walk through the one below that's very similar to it. So to start with, we need to, if you look at page 160, we need to figure out our numerator first. And so we get this, let me see if I can pull the formula just a second. Bum, 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 bum. This one here. Okay. So we get this formula, and we've got the identifiers here. They tell us the sample size of the group, our observation average for the group, minus the overall average of the observations, and then divided by the number of groups. Okay, so when we start to look at this, let's look at this. I'm going to blank this out, okay? Because we don't need that one anymore. Let's leave that here. All right, what's the first thing that we need to do with our pieces here? What do we need to identify first?
We need the overall mean, don't we?
Yep. So all I did was just run the average here. Okay. So we have the average of our 4 sample means. Okay. We got group 1, 2, 3, and 4. Each one was provided with a sample mean, and then we need to get the group mean, which is identified here. Okay. Average for group 1, which would be this, minus the overall average of our observations, which would be our 11.315. Okay. So what I went ahead and did is let me put my formula in here so you can see it. So we took, of course, it's going to cover this. We took our sample size, right? Sample size for the group, NI, right here, times our group mean minus our overall mean. And then I squared it. Okay. So we took 35, which is hidden behind this cell here, times this minus this to the second power. Okay. So this gives us our numerator here. Did I not save this?
So that column, you figured each numerator independently, is that what you're, or each
Yeah.
group independently? Okay.
And just one second. I thought I had. I thought I had the labels for these down here. Okay. Okay. So this is the sum of squares for our treatment. Okay. That's that SSTR. Okay. So we'll stick with that for just a second. And these are kind of the layman's terms of this, which they don't really go into the textbook with the textbook. But I thought it was important. So this is the sum of all of those here. Okay. So again, this is the numerator of the numerator. Okay. And so what we take next is we take our sum squares of the treatment, and then we divide it by the mean squares of our treatment, which is what we're going to get when we divide it by n minus 1 or k minus 1. So that's there. I apologize. So when we look at that formula, we take our sum square of the treatment divided by k minus 1. So the number of groups, which we have 4, minus 1. So that's going to give us our numerator. So it's 4.4. Yes, question?
Yes, I have a question here. So for this sample size, isn't it the same for all of the groups?
Yes. Yes, but that's for this one. Now, when we get to the denominator, it's going to be a little bit different.
Gotcha. Can you select cell number E10, please?
Oh, you meant this sample size here in terms of the formula? Yes,
Okay.
it is. Now,
gotcha.
however, I want to note in the question from the textbook, the sample sizes are different. They are 22, 31, and 52, but it's the same exact formula because you're just attaching the sample size times the average hours for that group minus the mean for the entire observations squared.
Okay, thank you.
Okay. Hold on, I can't hear you very well. Who was talking?
It was Eva.
No,
Oh.
I did not say a single thing.
Oh,
Oh, okay.
Sorry.
Okay. It might have been somebody just, I think Anish just joined us. It might have been in the background there. Okay, I just want to make sure it wasn't a question. Okay. So that's going to be the numerator there. All right. That's going to give us our sum square of our treatment and our mean square of our treatment. Okay. Next, we're going to start working on our denominator, which is the sum square of our errors and the mean square of our errors. Okay. So again, this is what we're doing here is continuing our utilization of the standard error of the mean. Okay. So when we look at this, we need to do S squared. Now, again, what is S squared? What is S squared?
The variance of the group.
Okay. So it's already given to us in this example. Now, I will say in my example, there was a standard deviation provided, but what I did to get the variance was just take the standard deviation squared, and that gives us our variance. So that S squared is variance, S would be standard deviation. Okay.
okay. So I get confused here because S squared lowercase s squared and capital S squared, I think are two different things. And then I never know, like, even with the problem that we were given, if it's already squared or not. So can you help me determine?
Yes.
I mean, if it's
If
a variance, should we assume that it's squared or?
You must assume that it's already squared. If it's the variance, it's squared.
Okay,
So
so let me
again-
stop you right there. Sorry, just so I can also understand what she's saying. So if it's variance, then it's already squared. If it's not variance, then it's not squared.
Correct. So remember, our variance is basically this right here.
Okay,
Okay, that's the same model. You take your observation minus the mean to the second power. And then that's going to be then divided by, but basically the variance is given in the question that we have. So, oops. But again, it isolates it as the variance of group I, okay? So when variance is provided like it is in that question, yes. Let me see up here. So these are the variances that are provided. So that means they're already squared. It's already S2. So this might as well just say S2, okay, instead of variance. All the legwork's been done for you. However, like I said, if they were to give you standard deviation, like in the question that I have, to get variance, which you would need to do this problem, you would just simply square the standard deviation, because remember, standard deviation is the square root of the variance. So if you're provided with standard deviation, you just need to take it to the second power to move it back to variance. Does that make sense?
now it does.
It what?
Now it does.
Okay. So again, make sure you pay attention to the symbols. Mandy, I don't know what capital S and to the second power you're referring to.
Okay, so that may be a sidebar. When we were working
Okay.
on this before, when I was trying to prep this chapter, that was a conversation I had with Peter. And
Uh-huh.
I thought that he said that capital S squared was maybe the sum of the variance, but I can't recall.
It could be, but usually, yeah, I don't know why somebody would do that. Or they would just do the sum square of the error.
And the only reason it was concerning me was because on page 161 in the equation that you have pasted here, that looks like a lowercase s, but then it's in the explanation in the book, it looks capital. And so I was like, is there a
capital S. I got you,
difference? So anyway.
But no, there's not.
Okay.
And I honestly, I've never seen an S capital S. It's usually the lowercase s for squared for the variance. So, but what we're going to test first is this top part is called the sum square of the error. Okay. So we have to do what? Follow it along. Take our variance times the n, which is the sample size of the group, minus 1. So we essentially take equals variance times 35 minus 1. And that's what I built into this formula. Did it all the way down. And then what do I do with it? Since this is called the sum square of the error. Just sum them up, right? Okay, so that gives us the numerator of our denominator. And what do we do with the bottom one? This one can be a little bit tricky.
Is it sample size times sample size minus 1 times the variance? And then the sum of
No.
all those?
No,
Oh,
I
that's
only
okay.
summed the samples.
Yes.
That's how I did it, and I got it right though, George. So I don't know, maybe I'm confused.
Well,
I
hold on.
guess too.
Hold on. Before, but I'm just talking about this. I'm not talking about I don't want to divide this yet. What's this here?
Mine.
So what did you do on that one?
Just summed all the samples.
Okay, good. So, oh, sorry, I need to make this black font. Okay, so what I did there for the doggone it, the numerator of this one is ignore the G15, okay? We summed up all of the sample sizes and then -1 for each one. Now, you could go through and you could say sum of this -1 plus this -1 plus, but I just added them all together and -4 out. Okay, that gives us the denominator of the denominator. And now we go back, Jacob, and you're right. We take this one divided by the sum of those. And that gives us our mean square of the error. Okay. And the final step.
George, before you go on to the final step, can you, I'm writing all this down. Can you highlight the cell G10? Just to make, I just need to double check myself here.
Yep.
Okay, so.
Variance times sample size -1.
Okay. Thank you.
And now some of you, if you would use Excel instead of handwritten notes, it's super easy to build this and then just go, well, did it right the first time, move it down.
You know, I have it in Excel. My problem is, like, I see yours and I'm like, oh, yeah, that's how I should have done it. But I like, when I did my numerator, I typed out and I've got all of these parentheses and I get so frigging confused.
I
So I
know.
just,
Well,
I do it by hand to make sure I'm getting the right answer.
and that's okay. Well, and I'll tell you what, there's no right way to do it because Jacob sent me his and his looked entirely different than mine, but he got the right answer because he just used it as a calculator. So he had his built out a little bit aesthetically different, but all the calculations were the same. Paul?
Okay, so the MSE is that entire snippet that you have highlighted?
Yes.
That's okay.
So this is
Thank
the
you.
mean square of the treatment. Okay. And they don't call it that in the book, but I want to, it basically what we're doing here. This estimates the between group variability, and this is the within group variability. Okay. So this is our treatment. This has to do with our specific observations. This has more to do with just the variance in sample size. Okay. And again, if you look back to a couple prior chapters when we were working on some things, this kind of starts to stack in terms of the Z-score analysis as something similar, and then particularly with hypothesis testing. Okay, so when we looked at the T-stat is very similar to the F statistic. Okay, and T-stat's going to stick around with us, especially when we get into regression. But the F stat is very similar. It's just it's just a different test. Okay. So what do we do to determine the F statistic?
Divide the what is it, the sum of, or the between group sum of squares by the within group sum of squares.
The mean squares. Yes. The
Mean squared, yeah, sorry.
Yep, the mean. Yep. So because you want to do the averages. Okay, so yes, you just take this one divided by this one. Okay, and that's going to give us our F ratio. Okay. Now, what we don't have in this textbook and what is the table that goes along with F statistics. So what the book does is it preempts you to the p-value. Okay. So when we're thinking about the p-value that's associated with this, which I don't have for this because I was not doing the math to do it, but there's a table that would be associated with this that says, just like the T statistic, what is the probability that we would see an observation of this size? And if it's below 5% alpha level, then we would have something of statistical significance. I can't remember what this one is, but I'm assuming that this one would not reject, that we would fail to reject the hypothesis based on this number. So just let me pop out real quick. Yeah. Yeah, you don't even have to do that on that one. Okay, so, but you do have to look at the F stat.
Did he just freeze or it's me?
Okay, you froze there,
at
George. We
those.
didn't hear anything.
Oh, sorry, I was just whistling to myself anyway, so it's fine. So yeah, when we do one-way analysis of the variance, again, I think if you put on like the Bartlett's test for equal variances, which is kind of a test of best fit, you'll get chi-square and a probability, but we're not doing chi-square in chapter 10, okay? But what we're going to get is an F stat, just like the T statistic. So it's going to look a little bit different in the stata output. So it's going to say probability greater than F. Okay, that's going to be our p-value. So when you get those outputs, if the p-value again is below our alpha level of, let's say 5% typically, then the likelihood of getting that F statistic again is extremely rare. So just kind of look through those. Again, it's not going to say p-value, it's going to say probability, and then they have the greater sign than F. Okay. And then for the exercise 2, you don't even have to do the p-value. And then exercise 3, you do have to figure out the regional differences between endowments at universities. Okay. And let's see. And you don't have to do question 4 in ANOVA. Okay.
I do want to ask you, how do you compare the Kramer's V value with alpha value?
The which one?
The Kramer's.
Okay, so in chapter 11.
Yeah, because there was one exercise that we, had to kind of identify what the Kramer's value is, is saying.
All right, so yeah, very, very similar goodness of fit test in terms of analyzing the variance between two groups. Okay, so in the first question, you're going to look at whether males or females, what's the null hypothesis here? Is the same proportion of men and women have never misused pain relievers. Okay, so when you run the table or the tabulate in terms of those particular variables, and then run the chi-square and the Kramer's V, you'll get a specific answer on this. And this is the interesting part, because I know Mandy brought this up. She said, well, there's not much difference between the two. You're right. It's a very nominal amount, but it's statistically significant based on the data that's provided. Okay. Now, that being said, it is statistically significant, but based on Kramer's V, which is basically the correlation coefficient, the effect is extraordinarily nominal at best. Okay. So while it's statistically significant, the actual effect of one standard deviation or above or below is tiny. Okay. And so again, you'll see a little different output with chi-squared in terms of grouping male versus female who have never misused or have misused, and then it's going to give us the chi-squared of the out of those results. So it does all that work behind the scenes, thank God. Because
when you see those values that they listed in the book, and it says like there's like less than 0.1, it's small, and then less than 0.3, I think they count that as medium. And then when you have to like compare that with the I think we had to compare with a probability or the alpha, something like that. How do you Okay, let me put it. How do you even write it down?
Well, just like they did in page 180. So again, if your Kramer's V, just like the example I was talking about out of the book, it's a very, very minor, it's between small and moderate effect. And again, this can be positive or negative, okay?
Yes,
that's
because I got
basically-
one negative and one.
So it indicates there's a very weak correlation or a weak to moderate correlation between the two variables. In other words, gender is a significant factor in determining views on death penalty. That's out of the chapter, but only has a small effect. Okay, so you will most likely encounter something similar to that with the exercises. And then in 6, in each chapter, it talks about presenting the results for a non-technical audience in a scholarly journal. And so that's where it really breaks down how to articulate the outputs. So again, using the example of 11.2 in favor of death penalty or opposed, you see that the x squared is 12.36. The probability is 0.00. So that's definitely below the null. However, I can see at Kramer's V is 0.08. That means it's a very insignificant or considered small effect. So as they state, a chi-square test for independence indicated that there is a statistically significant difference in the percentage of men and women who favor the death penalty. And then that's how you have to write it out. X squared 1 equals the n of 1824, the total number of our observations, equals 12.35 with a p-value of 0.00 and a Kramer's V of 0.08. So in that data set, it says 69% of men favor death penalty compared to 61% of women. So while statistically significant, the effects are weak in terms of Kramer's V.
Do we use the absolute value of Kramer's V, or if it's negative, is it always going to be small?
No, it can increase more as correlation does. Again, correlation and Kramer's V can be -1 to +1. So 100% correlation, both negative or positive, is possible. However, highly unlikely.
Mandy, if it's negative, it just means it's inverse. So it just moves opposite.
Just a
So-
negative
so-
relationship. Yeah.
If we had a Kramer's of -0.5, we'd still say it was a large difference, but in the negative direction?
Yeah.
Okay.
Yeah. Because that would be a 50% correlation, right? So again, we're looking here at Kramer's V small is 10% or below. Medium is 30% or below, and less 50% is large. Because you're rarely, if ever, going to see anything of statistical significance that would be, my God, that drastically different. And a lot of this will carry over into regression next week. So please pay attention to, what we're trying to achieve here with the p-values and the correlation coefficients. Chi-square will disappear, ANOVA will disappear. But in terms of what we're going to be doing next in regression, it's very similar, right? It's going to have a t-stat. It's going to take mean or observation minus mean to figure out the variance. It's going to do all the things we've already learned how to do in the prior 5 weeks. And it's going to repackage it to be more of a correlation coefficient than anything, okay, with either a statistically significant p-value or not. And instead, it does all that work for us. Okay. So again, this one really wasn't too bad. Try not to outthink the coding on this one. I mean, the chapter tells you exactly how to do it. So don't try to outthink the room. Mandy. Your email's like, oh, I guess I made that way harder than I needed to. I'm like, yeah, you did. which is hard. I mean, sometimes it's like, oh, it has to be more complicated than this, but it's not. That's what these statistical software programs are designed to do, not make our lives a living hell so that we don't have to do every one of these on paper.
If this
Just-
is not hell, then what is it hell then?
I can take the software away next term, Eva, and let you do panel regression by hand.
No,
Okay. Does this clear up the question you had about you were real close? You missed the one divisible on that one. So but yeah, the crazy part is I don't think a lot of you will use chi-squared. I rarely encounter it in my work, but I don't deal with a lot of categorical stuff either. So
Haha,
But-
we use chi-square all the time in genetics. So
Yeah. that makes sense. Yeah, right. That makes sense.
I mean, a lot
Uh,
of my data for this project is actually categorical. So I
'Cause you're-
will need to, go ahead.
Well, because you're meddling around in psychology and ADA stuff, right? It's not just straight quantitative stuff, which is all I
Yeah.
deal with. So, but again, I would like in terms of the chi-square, we talked last week about the normal distribution, right? Just the normal bell curve. Chi-square, make sure you read 11.3 because chi-square is a little bit different. We're testing out to the tail. But chi-square will never be negative. Okay, so we're trying to figure out the likelihood of finding that value out there in the tail. Okay, so look at page 175. Give that a review. So those who might stumble, Paul, you'll probably get into that in terms of what you're looking at. So there might be a utility for some of you in terms of chi-square. But look at how that distribution pattern shifts compared to a normal distribution, okay? But yeah, I mean, it just depends on what you want to study. I have never encountered chi-square. And I will say in terms of some articles, Jamie's not here, but she brought me an article that she wanted to do for her review. And it was, I want to be clear, there are very bad articles that are published, okay? There are very bad journals out there. She happened to stumble upon one of them. And they mentioned their chi-square analysis, but it was nowhere to be found in the article. I rerouted some of her numbers and they were off by 4 observations. And, sometimes stuff happens. So be cognizant of that fact. If something doesn't seem aligned, it could be the way, I think with hers, because there were several journal articles that we looked at from that journal. I think it was the way they published their data, that they talked about all of their testing they did, but they only listed the significant information. So chi-square must not have been statistically significant. Thus, I would say, don't bring it up. I don't want to hear about it if you're not going to put it out there in the tables. So, because nowhere was it listed as, X square is this greater than this, and then with the actual chi-square. So just be careful out there. There are journals that, you can get anything published on if you pay for it. So just be careful with what you're stumbling upon. Try to stick to the quality journals. I understand that the library has more access in JSTOR now for business journals. So give that a try. Yeah. So I don't know, this week to me, and again, it doesn't seem too bad in terms of workload other than trying to figure out your methodology, but you should have a solid understanding of that already based on your literature review that came from a couple weeks ago. Okay. You don't have to create anything new. Let the academic literature guide you.
Until today, I thought that was cheating, by the way. Jacob laughed at me.
That's not cheating. As long as you cite your sources and you're not saying it word for word. Even there is literally nothing new to say in the entire world. Humankind has run out of crap to say. It's all been published. It's all been done. All we're doing now is finding these itty bitty little slivers and recreating something that someone else has already done. Okay. Now I will go out on a limb and say, yes, the economists and theorists at Harvard will probably come up with new theorems, but we ain't that. Okay. It's okay to accept that. All right. Paul.
So like when we do our dissertation, they keep telling us it has to be something original. And I keep thinking of what you're saying, that what is left original out there, we're not. So how do we reconcile that? And you froze again, if you can hear me.
So I had this question for him as well, like I discussed with him a couple of weeks ago, and because I had a same perception as you are.
So I mean, I think he's saying
when-
you're not creating a new theory. Like you can add to the literature, but you're not coming up with like a new theory. Like those are kind of separate questions, right?
They meant by original work, it's something done by you, but what you're gonna be doing, we're gonna be doing like a pliable project, which means something that was already kind of done, but we're trying to, like redo it again and see if
So
we
like
can, find
the
something.
theoretical framework, like good.
I got dropped. I apologize, Paul. I heard must be original, and then my internet dropped out apparently.
So with our dissertation, they keep saying it has to be original work. But I was thinking, like you're saying, that we're not going to come up with anything totally original. It's highly improbable.
Correct.
So how do we reconcile that?
Well, you're looking and you're letting the literature guide you in those gaps. So, like I've said, almost every article in their future research or limitations section identifies gaps that they missed in their literature, what they found after the fact. So let me read you, and I will bring mine to some of mine. I'm not gonna let you guys see how bad it all is, but so in my and this is probably overkill. My first 10 pages, 6 pages, I have 50 citations to source material. And again, that's for my dissertation. However, I will state what I've done there is gone all the way back in terms of executive compensation and theories of the firm, and started with 1976, Jensen and Meckling, who created agency theory, and all of the subsequent contractual and entrenchment hypotheses associated with developing protections against agency problems, like over aggressive CEOs who make poor decisions and questionable risk taking decisions, or the inverse, where they don't do anything. So I go through and I just lining it out, start with the importance of executive compensation and why it matters. Kind of go through the literature on that, why it's important in modern times. Roll all the way back, look at what principle is, agents are, yada, yada, yada. Alignment between the two is paramount. Empirical testing. So then I start to drive towards, here is what the established literature says and why it's a continued area of interest. So within my particular topic, what's interesting is no one knows if CEO compensation or incentivizes higher firm performance. Some studies say it does. Some studies say it doesn't. That's why it's continually tested. Because depending on it can be yay or nay. Yeah.
Oh, sorry to interrupt. So I was just gonna say, so I mean, to me, like what I'd said, the nuance there is like you're not creating a theory. Like that's the distinction.
Yep.
Like you're doing, yeah, you're exactly.
Yep. So, and then, I break it down and I just start with, I'll read you the first sentence of my paragraphs. Empirically testing the direct application of agency theory and its various components has led to a better understanding of the relationship between principal and agent. Citations, examples, the empirical results published in academic literature deliver mixed results in evaluating the relationship between the two. Thus, further investigations needed. Academic literature continues to empirically test the linkage between that and for performance, whether it is positively or negatively correlated. I give examples of both sides. Go into optimization of compensation packages, go into equity-based incentives, risk absorption and risk taking. And then what I started to, and this is where I go through all that baseline surrounding the area of interest I have. And then I say the established literature suggests the banking industry offers a unique opportunity to empirically test managerial risk taking and its relationship to executive compensation structures and firm performance. I use the global financial crisis of 07-09 as my baseline. So in the years running up to 2007, there was an increase in the utilization of risk-taking incentives embedded in bank executives' compensation. So basically what the fallout has become is the bank CEOs were engaged in highly irregular risk-taking because they were incentivized to do so based on their compensation packages. So there was socio-political fallout from that, yada, yada, yada. It turns out it was misalignment. Okay. So here's where I deviate into my area. The academic literature in corporate finance is well established regarding agency theory, executive compensation, corporate governance, and risk management. The COVID-19 pandemic tested the limits of the global economy, central banks, and the banking industry. The impact of the pandemic, blah, 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 blah. This research relates to several strands of academic literature: executive compensation contracting, firm characteristics as determinants of executive compensation, risk-taking incentives, and CEO ownership concentration. And so this research aims to investigate trends in CEO compensation and firm performance in the banking industry during the COVID-19 pandemic. To my knowledge, no papers have analyzed the banking industry in terms of the effects executive compensation packages and risk-taking incentives had on firm performance during the COVID-19 pandemic. So here are my guiding questions. Were the same or similar risk-taking incentives, ideally pay risk sensitivity or VEGA, that preceded the global financial crisis of 07-09 present before, during, and after COVID-19? If so, what was the underlying effect on firm performance and bank CEO compensation? Were banks with higher CEO ownership concentrations more insulated against the exogenous shock of COVID-19? Analyzing these questions allows me to research and empirically test, establish theoretical concepts, and add new results to the literature. Isn't this fun? All right, that was 50 freaking articles in 7 pages. Okay, so got a lot of reading to do. And then what's cool about that is those are all in there. And next, so that was just the intro to the intro. Next is my significance of the problem. Why does it actually matter? And so in the main question I'm looking at, did higher levels, probably I'm thinking 10% higher levels of CEO ownership concentration in their specific bank insulate them against risk? In theory, they should have been more risk averse because their compensation was associated with firm performance at a much higher level than the average industries. However, I won't know until I actually test it. But my hypothesis will be, yes, they were more insulated against exogenous shock of COVID-19 than those who had no or below 5% ownership concentration in their bank. So I'll use stock option volatility, which is VEGA, for that, and test it. Don't know, don't find out. So that's once I'm approved for that, then that's when I start to collect my data, because I'm not doing it until then. So yeah, that's pretty much it. And so what I'll do and what we'll learn to do is like a difference in different study. So I will use March of 2020 as my break even. What was executive compensation and firm performance up to the announcement of COVID-19, like March 18th or whatever it was. And then what were the subsequent results since that time? And that's where I'll be able to identify whether firms with more or less ownership concentration perform better or worse, or the same. So hope that helps. Just use the literature. So again, I'm not creating anything new, but no one's tested this yet in terms of what its relationship is to COVID. Mostly because the big boys and girls, they won't test it until they have 5 years of data. So they won't get to it until 25, 26. It probably won't get published till 27, 28. So I can find a little sliver in there that I can attach to optimal CEO compensation and ownership structures. So that's all I'm doing. Find a sliver. But again, where I started was the broad agency theory from 1976 and came all the way down to optimal compensation structures and CEO ownership and the effects on firm performance. So that line trickles all the way, literally from 1976 to 2023. Okay, so again, start big, look for those seminal works that were foundational in your area, and let everybody kind of guide you along the way. And all you're doing is taking the little sliver from each one. How'd they do it? Why'd they do it? What are we finding? That's it.
And you found similarity in how they gathered that data, because what I'm finding is like the same author, he's doing the same tests, but then I'll find another study and they do other stuff. And it's like, well, I don't know which one's better.
Well, I mean, as long as they're both statistically accurate, there's no better or worse. The brilliance of academics like that is they find a model that can be replicated over and over again so that they can publish over and over again. Dr. Koch, his mentor, was one of the biggest marketing professors from the West Coast out of Stanford. And that guy published a bazillion articles, and he said, you know what he did every single time? Same framework, different stuff. That's it. And so, and once you have your foot in the door from the R1 publish or perish, situation, then, you publish one in the Journal of Marketing, you're set. All you got to do is call them up the next time they got another one. So again, you're going to see that replication throughout sources. But yes, there are some more, the newest one from 2023 for me is looking at some international factors, or some have thrown a layer on of CEO country of origin. Like they're just adding factors to these quantitative studies that are already out there. Again, no one's coming up with anything new. We use a Black-Scholes model for my stuff for looking at optimal option valuation and volatility. It's got limitations, but everybody accepts the limitations in the literature. So you just go, hey, that works. Let's do it. So you'll see what it is. And if you read those articles like I had you do last week, and you really get down to the limitations or the assumptions, they will identify those for you and say, this is a limitation that we found within our research, and we need to either modify it, or we accept this limitation because of X, Y, and Z. So like for mine, I am just like all of the foundational work, I'm arbitrarily assigning CEO ownership at 5, 10, and 20%. There is no reason as to why we do that. There's no justification that says one's better than the other. But all the prior literature uses it because some genius from the 1988 did it. And so we are sticking to our guns and saying that works well for us. So just trust the published literature that you're reading and use it to drive you forward. And don't hesitate. If it says, Nolan 2020, posited that ABC happened, and then Fields is cited next, go grab the Fields article and see what they had to say. It's that easy on Google Scholar. Just go get it. And then stack that into your research, because you really only need a sentence or two out of each article. If you're thinking about just the lit, if we're talking about the quant stuff, that's a little more, but we're just not quite there yet. Hope that helps. And if it makes you feel better, I still don't know what the hell I'm doing half the time. So just roll with it. Get comfortable with being uncomfortable. So
good to know. If someone asks me, do you know, I'm just gonna say, well, even my professor doesn't know either. So whatever.
If you get a chance to ask Dr. Jacobson, what the biggest shock of moving into academia is, I'll let him answer it. But I would have to agree that not all of us know exactly what we're doing all the time. It might seem like
I know that. I thought that I know everything about EMBA, and then I was like, no, I know nothing.
Oh, and that's the right attitude, because we don't know anything. Even as much as I've read, 2% of articles on CEO compensation and for performance. I'll never know it all. There's no way to do it. Don't assume you will. find your sliver and become the master of that. That's it. Okay. I will release the residency schedule at the end of the week. It sounds like we have dinner on Friday night and then lunch. Okay. All right. So I'm going to send out an email for any dietary restrictions so Peter can get that ordered. We'll have coffee. It sounds like Saturday morning. I guess we don't get breakfast.
George,
So-
just a question, since that's a moving day in the campus, do you think the cafeteria is gonna be open as well?
Mhm.
Okay.
But it's going to be absolute chaos down there.
Okay.
Yeah. But we're going to be up in the president's boardroom. We'll be fancy in front of everybody. So, yeah, but yeah, the plan is stay focused on your final project because there'll be a presentation on it. Okay, and kind of where we're at, going through the research problem, lit review, model, methodological approach, just kind of the opening salvo of starting to examine and critique some of the approaches. So, all righty. But again, that will be built off of everything you've already done. So you're not doing anything new. You're just repurposing it into a more formal presentation, like you were doing a dissertation proposal presentation. So, and we'll do it again in 5 weeks, something like that. So, you all shall survive, I promise. All right. Let me know if I can help. Is there any other questions? Okay. All right. Like I said, I've spent the last I don't know, 36 hours of 48 writing. So if you don't have anything, I'm going to go away. and
Okay,
take
but
a
how many
break.
pages have you written?
In total? Now, good or just in total?
Just in total.
About 84.
Oh my goodness.
What?
And you're not nearly even like half done, right?
Yeah, the first 3 chapters, I mean, give or take, they'll probably chop some of that out. So I imagine the first 3 chapters will be in the 60s. They usually they got a lot of the unnecessary stuff that I throw, that people throw in there. It's just part of it. So I'll tell you, my master's thesis was 124 pages and I submitted it. It was like 148. It hurt a lot when they gutted 20 pages. Like, damn, that was a lot of work. So they just trim out the fat. They get you down directly to the point, like we talked about, clear and concise. And sometimes we get a little too far out there and like, oh no, this has got to be in there, and it really doesn't. So you'll figure it out. Again, you guys, some of you are brand new. Others have been out of a term or 4 or 5, and so you'll get there. It's all part of the process. Doesn't mean it's any easier, Eva.
Why are you cutting me out?
Because you're the ones like, I quit everything. And so I got to remind you.
I'm not gonna lie, guys. I'm one of those who does math and by hand because I really don't know how to use Excel for math. I use Excel for everything else. Like for my financial side that I run in the department, I know that, but for math, no. So George, it took me a while yesterday.
I know.
It took me a lot.
That's why I kept emailing you back at 9:30 at night. I was like, that's fine. I'm just sitting here writing anyway. I don't care.
And
So-
and eventually when you said this is correct, I just threw the books, notebooks, everything, and I left the room and I was like, I'm not touching this again.
Well, you know what? Jacob needs to just lock you in his office for like a month and let you learn how to do Excel.
I just actually talked to him and he sent me how like some videos that I can watch and how to do it.
Mhm.
Well, it definitely takes time. The first week in my job, they took my mouse and I wasn't allowed to use a mouse on the keyboard. So
I love it.
definitely a learning curve.
No.
Yeah, but once you get there, man, you just fly. You just
Oh, it
fly.
hurt me to watch you move the mouse around the sheets. That's pretty inefficient, but I get it.
Oh, I know, but I do. You gotta understand, man. I teach mostly undergrads, and it is a step-by-step process. And if I were to even hit Alt, they'd be like, "What did you just do to the screen?" And then we'd spend a week talking about the Alt function. And I don't have that bandwidth in me, Jacob.
No, that's fair. I honestly don't even think I could describe what I did half the time. it's just movement.
Yep. Luckily, if you mess up, you can just Control Z it and back it on out a little bit. So, all right. Well, happy week 5. We are past the halfway point. Y'all are doing great. Keep it up. Let me know if I can help with anything. If you do have questions about the assignment, stop texting each other and just email me. Okay, please. So let me provide clarity. You don't need to think about what I want in my assignments. Just reach out to me. I'm always right there. Okay. So
Are we gonna see you tomorrow in office? Nope.
I don't know if I'm coming back, man. I don't know if I'm coming back. I just don't know. We start classes on the 7th, and
Hey, Chad is providing barbecue tomorrow. You might wanna come and have it some.
nope. I don't think I can do it, Eva.
I was trying to get him so he can come and then I can hang in his office and do this assignment.
My summer went too fast. So, all right. Well, I might see you Thursday, though. I don't know. We'll see. But I hope you all have a good week. Please let me know if I can help. If you need help with the data sets, do reach out. But also be thinking, if you're struggling with that, to kind of think, maybe just move to the right a little bit or the left and see if there's something that could be repurposed into that topic. Okay. Doesn't have to be perfect. We just got to get something we can do. All right. Well, like I said, I'll get the residency out. And if you need anything else, let me know. I will get this video posted for our absentee colleagues, and wish y'all the best.
No,
Thank you.
Bye.